Hi everybody, welcome back to the C# Basics course. It's been a while, but we're going to get right into generics. If you're coming from a language like C++, generics equal templates. Basically, it's just a way, so that way we don't have to statically define what type we're using in our class. So this makes totally, complete, perfect sense. I think I can do this. Can I just create a new class? Are you going to yell at me? Yeah, I don't think I can. Alright, cool. So I had to move the class outside of the class. Basically, we just have angle brackets here, and we use angle brackets, and we say that it's T. So we're going to use whatever type. I'm actually going to expand that out to say type. Well, we're just creating a new stack class. So create position, we're going to create a new type array named data. Say new type. And we'll say this holds 20 types. And then the two basics of a stack are push and pop. So we'll say push, type, say type. And we're going to use our little lambda expression. Say data at position plus plus equals type. And then say public type pop. And it's going to return the last item in the array. So you can just see, so basically we don't have to say, oh, this is going to necessarily be an int type or an int stack or a double stack. It can be a type stack, and it can be all of those. And this helps with maintainability of code. I can't talk right now. So basically this just helps with maintainability of code, so that way we don't have to statically define the types for each different type. And then what we can do is come back up here, and we can say a new stack will equal a new stack with an int type. So, and still a class too, so we have to pass in our parentheses. So what I realized here is, like, we also created an object array, which was pretty open, you know, and pretty flexible with whatever type we want to use. The problem with that is that we basically have to make sure that we're boxing correctly and doing the up and down cast, which I made a video on with that whole object type stuff, and it can cause problems. So this way, you know, if you're going to have a class that's going to be using the same data type throughout, it's good to use generics because it reduces your code load. I like that. And you don't have to do anything with boxing, downcasting, and stuff because you're using the same type. And this is pretty cool. So we can create a generic class, but we can also create generic functions as well. So we'll say we're going to create a swap, and it's going to be type as well. I really am struggling typing. And then we're just going to create a new temp. Say this is equal to A. And C# has no idea what I'm saying when I pass in A, so we're going to say type A, type B. And these are going to be two of the variables that we swap. And we say A equals B, and then B is equal to temp. Boom. So now we have something that you can use any type again, int, double, whatever you want to do, and it will swap the variables, which is perfect. You know, we don't want to say, here's an int swap, a double swap, etc., because it's not really helpful. And I just really am focused on code maintainability here and making clean code, and this is one of the ways that you do that. Oh, and if we were to actually be doing this, we would want to say ref, because this is how we pass by reference instead of passing by value, so that way our variables actually do change. So we can actually pass in more than just one type as well, which would make sense if we were doing something like a dictionary. And so we'd have type key, and then we'll have a type for our value, whatever is within there. So I'm not necessarily going to build out this class, but you can see, like, if we're going through a dictionary, we want to find the key, but that key might not, it probably doesn't have the same type as the value. So we want to keep it flexible as to whatever the type the value may be, because it's not necessarily the same type as the key. One thing to know is that we'll just create a new method here. I'll name it default, and we're going to pass in a type. And so basically, if we were to pass in a type array. So with this default method, we can go about and create a new array. Say, well, I is less than array.length, and I++. And then at each array index, we can initialize it to the default of the type. And so if type is a reference type, which is any object, and strings as well, basically non-numeric types, it will default to be null. And then if it's a value type, so basically all numeric values, and that's about it, it will be equal to 0, whatever that 0 is for that specific type. And that's it for our first video on generics. Thanks for watching.